Hello, the objective of this exercise is to apply the NB rules to estimate the effective breadth and the maximum normal stress of a transverse part of the dig. According to the NB regulation and by inspection of the plane, L is equal to 69.12 meters. The element we were analyzing comes from the dig structure. The beam flange was dimensioned with the AutoCAD program. The effective estimate was obtained in two ways, geometrically by the DNB rules and by the AutoCAD program. When comparing them, the same values are obtained, and it is also observed that the effective stiffness is 78% of half of the beam. Applying the DNB rules, we first identify that the deck pressure for weather digs reached a value of 10.87 kilonewtons per meters square. For maximum bending moment, we first identify the element is a clamped support. In this case, we apply the equilibrium equations for the bending moment distribution, and the boundary conditions for clamping is equal to 0 and L. The slope and the deflection is 0 in that point. Then evaluated the boundary conditions, the values of the constant is the next. If we observe the bending moment distribution, the maximum value occurs in the middle of the beam, and the other way, in the ends, in the extremes of the beam, the bending moment is minus 46.71, and the bending moment maximum is 23.35, and in the same way the deflection distribution is maximum in the middle of the beam. To estimate the effective breadth, we define these parameters according to the beam flange dimensions. Interpolating the table C1 for the values of the C, we obtain an effective breadth of the 0.996 meters, and which is the 37% of the real dimension of the beam. Finally, the maximum normal stress. First, we will obtain the inertia effective with the effective breadth, and for the dig plate and flange, this value we will obtain